Hello, everybody. Welcome back to our session on Python programming. In the last session, we spent our time discussing a recursive implementation of a function where you're trying to check whether a given integer is valid or not. So our entire session was devoted for that discussion. Today, we plan to start with a new topic. Today's topic for discussion is something called as annotations. Now, the term annotation you will come across in different programming language, especially when you learn Java. Now, if I write those annotations or if I do not give those annotations, it will not have any impact on the way the program runs. Mark my word, irrespective whichever language you use. So right now I'm talking about something which is common for all languages. So annotations are more like comments. Now, when I say they are more like comments, comments are anyway ignored by, don't say they are comments. I said they are like comments, but they're one level higher. Comments, when we write in a program, they're always ignored by the interpreter, by the compiler, and so on. So whatever comments you write in the program that are never available when the program runs, they act as source of information about the logic or something only to the developer who sees the code, nowhere else. But annotations are like additional notes about your program or the elements within the program. And they're not just available to the developer or the guy who's mentoring the code. They're also available at runtime, or they can serve as a tool of communication using which you can communicate with various other tools through which the Python program runs. We had seen one tool like MyPy, if you remember. And if I had a final variable, if I try and change the value of final variable, it did not generate any error in Python. But when I ran that tool through MyPy, it identified, oh, this is a final and you're trying to make a change. That's line number so-and-so is an error. Likewise, if a variable function is expecting the function parameter is of type integer and you pass a string to it, Python, otherwise, even if I said :int, Python had nothing to do with that. When I ran that through MyPy, MyPy immediately told us, oh, function is expecting integer and you have passed string. So those after the parameter name, when we put colon, we say int, yeah, string, and it returns something list, that's what we are writing, were all those annotations. They were additional information about whatever we have written, but they can be processed by various tools. MyPy was one such tool which processed this additional information, made use of that information to check whether you are executing the code properly or not. So likewise, we can have annotations which can be interpreted, processed by various tools. And we have seen annotations for functions where we have been saying the first parameter should be of type integer, second should be of type float, and then we are saying it should return a list or a tuple or whatever it is. That was additional information. Python interpreter really had nothing to do with that. So there are annotations which can be, or they act as a tool of communication with various tools. It could be interpreted, it could be debugger, it could be tool like MyPy and so on. So it gives us an opportunity to talk to various tools. It gives an opportunity to give additional information about the code that we have written. So you can think about annotation as one level higher kind of comments, which can be used to pass some information to various tools. And then the tools will know what to do with that particular code. So let's have a look at the concept of annotation. We can annotate arguments and return value of a function. So if there is a function, and we have been doing that unknowingly, we have been saying the first parameter should be of this type, second should be of this type, function should return something. Those are nothing but annotations. For arguments, the syntax is argument : annotation. We have been saying the first argument is like count, that's of type integer. And the return type, we have been saying arrow, list, whatever it returns, and so on. When running the code, you can also inspect the annotation. They are stored in a special .dunder annotation, dunder attribute of a function. So they are there. We can access it if we really want to. So let's see where the annotations are stored and how we can access it. And then we'll go through the step where this concept of annotation was used, and we'll look into the motivation as well. So let's go to our code. This is our code. Note, we said is palindrome. That's number. Number is of type integer. Function should return Boolean value. So that's annotation that we have given to that particular function. So suppose this is a function and we have annotated that function. Function definition is there in the memory. We have annotated that function and I want to know the annotations. What I could do is I could say is did I spell it right? Oh, I put three things, two down. So it says annotation will say number is one parameter which type is integer and the function is supposed to return a Boolean value. It is not just with that function, it could be of any function. Suppose there was a function which takes in more than one parameters. So luckily these are all functions taking only a single parameter, but we have written earlier functions which takes in more number of parameters. So let's say we have this function which takes in more number of parameters, get student pass list. We have annotated that particular function as well. So if I keep this function in the memory and I want to know what are the annotations, so at runtime I can actually check dunder annotations dunder. It's telling one of the parameters of cutoff, which is of type integer, and returns a list. Okay. Note, we had not annotated this parameter, correct? We did not annotate this parameter. Had we annotated, that information would have also come in. So whatever are the parameters which we have annotated, for the parameters we say colon int and other things. For return type we say arrow list and so on. Believe me, this kind of naming mechanism is now available in C++ as well. Probably you will see in C as well. So those in colleges, if you had thought about this and you felt, array, ye to nahi tha C mein, ya C++ mein. Now it is available in C++ as well. You can specify the return type later. A return type you can specify later. So that was a very brief thing about annotations. But once you give these annotations, keep in mind various tools will be reading this annotation to check whether we are using the functions, the code, the classes correctly in the program. But it makes more sense for us to look at the PEP to know what was the motivation regarding giving such kind of behavior. So let's go to PEP for annotations. So here we have function annotations, we have typing. There are two different PEPs. Let's talk about this. Go and check this PEP. So if you go here, the creator of Python, he himself was the fellow, he came with this particular concept along with somebody else. And 3.5, 2014 May, this particular concept was introduced. So the name has a parameter of type string, it returns string, that's annotation. And we had seen with our example as well. So rational kya tha? Added support for arbitrary annotation on the parts of the function definition. Although no meaning was assigned to them to annotation then, they are always been with an implicit goal to use them for typing hint. And that's what we are doing, typing hint. So we're saying the first parameter ka type kya chahiye, integer, string chahiye. Function return kya karega, to string type ka value return karega. So while you are using these functions, if you're catching the return value in some variable, so in that case, and if there is some mismatch, it will immediately tell us, oh, this type of data is being returned and so on. Implicit goal is to use them for typing hint. Okay, so that's the basic goal. Non-goal kya tha? Remain dynamically typed language, and authors have no desire to make the type hint mandatory. Yani, if the function is expecting integer and if you pass character, it is not going to generate an error. Like suppose we design a new function. I say def, and I have a function called as doit, and we expected this doit to have one parameter, suppose some data, and that should have been of type string, and this function is supposed to also return string, suppose. Okay, and what happened was I just say print if data is equal to data is what I say, and I say return hi. ऐसा कोई function है suppose. So we're expecting string, returning string, huh? But what if you don't follow don't do it with it's not mandatory. Means if I pass string hello, that's good. But instead of hello, if I pass 3.4, It's not complaining because it is not mandatory. So they have to keep one feature of Python alive. Python is a dynamically typed language. That feature is there. But then sometimes, suppose you're calculating compound interest, a simple interest, and you pass some strings, Anil, Sunil, Ganesh. So Anil, Sunil, Ganesh ka compound interest, simple interest find karoge aap. So that's not possible. So at times we want that thing to be done properly. That means if I'm giving a call to a function, suppose I want to do call to a function saying add two integers, suppose def add to int, ऐसा कोई function है, then obviously I would be expecting both the parameters to be of type integer, int comma int. And suppose the first parameter is a, that's the first parameter, second parameter is b, that's second parameter, and this function is also supposed to return an integer. No, that's what I'm expecting. That's what I'm expecting. But if somebody does not adhere to that, it is not going to complain and generate an error. So I had to say return a plus b. That's an integer. So this code will work for strings and this code will work for integers as well. So if I pass to this function add to int 45 comma 4, it correctly gives the answer as 49. So that's how it was expected to work. But instead of this, if I pass 4 and 5, we really did not want this function to work, but it gave you 4, 5. So it's not mandatory. But some places we can check this, whether it is as per our requirement or not. And there is where the MyPy tool came into picture. So let me just call it abcd.python and we'll run the MyPy tool. If it is installed, I don't remember whether I have installed it because it's a new system. If it's not there, we'll reinstall. Let me first check whether MyPy is there. It says there is not there. We'll let you install MyPy. Okay. So let me see whether I have it in Linux. We had installed, but I don't remember it was on the other system or this system. Not find MyPy install with so and so. Okay, let's install. Good bandwidth, it shouldn't take too long. Oh, yeah. So now I say, I go to the location that we are. I say cd, no, cd/mnt/d/tem. And here I say Python 3/abcd. So that program is ready. Now I want to check. Let us give a wrong call to this function somewhere. So suppose in this particular code somewhere we are not doing something which is as per the expectation. So here I go. Here we are. And I say print f string. I say 45 plus 5 equal to function is like add to integer and I pass 45 comma 5. This is what the code is. If I pass this and I run, it says 45 plus 5 is 50. Well, that's okay. But if I pass to MyPy, then what would happen? If I say MyPy abcd.py, it would not complain me because you are using the functions properly. Success, no issues found. But when you will find an issue, like what we did last time, 4 plus 5, then now we'll have an issue. If I go here and I now say 4 plus 5 is 9. Okay, and here I say FOUR plus FIVE. And if I pass those 4, 5, FOUR comma 5. If this is what I do, syntactically there's no issue. If I run this particular code, it's going to run. Can you see this? 45 plus 5 is 4 plus 5 is 4, 5. So the code is getting executed. But is that what we desired? We desired both the parameters to be of type integer. So if I use this tool like MyPy, it is telling us, sorry, line number 18 pe. It's saying has an incompatible type str expected integer. Second argument, argument 1. Argument 2 is also expected to be of type string, incompatible type string expected as integer. So now we have this annotation acted as a mean to interact with this particular field MyPy, with this particular tool MyPy, to know what is the function expecting and what you are passing. So it becomes quite handy while we are debugging the code or using such tools like MyPy. Here we go. So although it is not mandatory, but these tools will help you to write safe and neat code. So it says like name should be of type string, and you return the string. These are type hints that we are giving. So this is just a hint saying data should be of type string. A should be of type integer and B should be also type integer. So these are nothing but type hints. Okay. So here we could also set function is not supposed to return anything, none. That's also possible. URL should be of type URL. URL is like a pre-existing type, assume code, and a re-entry of type string. So now from typing import type var, iterable, variable, and so on. So there is additional thing like type var. Okay, it says type T can be of type integer, of type float. So let's look at this type var. Okay, so something more we'll look at type var. So it's again for type hint. So the same thing we're looking at. So let's look at this type var, new type, and type var. Where is type var? Where is it gone? So generic and parameterized factory available called as type var. It is a type var T, declare a type called as T. So I'm saying T is a type, and it could be of any type. So that's you use for generic, which we can talk about later. But we can say, oh, T is some type. So it should take some elements of that particular type and so on. So if you want me to use it and show you, I can just show you. I like over here, I can say I have a type var. For that, I'll have to import something. I'll have to import type var from typing. So if I import this type var from typing, then I can make use of it. I can say some type, I can give any name, A, B, C, D, but normally we say from typing we import type var. So I'll say T, as we said over here, is some type. Okay. So here we're saying type var T. So T is some type is what we're saying. We're saying T is some type. So when I say T is some type, now if I'm defining some function, suppose if I say def, there's a function foo, we have a parameter A, I can say variable say A is of type T, and it also returns type T. So you may not wonder what is T. We're saying T is some type. In generics, it's quite useful for us to write a code. I'll give a brief hint about what is generics. So we'll learn generics later, but let me give a brief about what is generics. Suppose I have some strings and I have to sort those strings. Listen to me very carefully. I'll give details about it later. I have some strings. If I have to sort those strings, so obviously you can sort it based on some parameter. Parameter can be length of the strings. Parameter can be the characters that are inside the string. A, B, C, D should be first, and X, Y, Z should be later, and so on. That's lexicographical comparison. It can be length of the string, the smallest string first and the largest string at the bottom. That could also be basis for sorting. But then at the same time, if I have some integers, or if I have some floating point values, and I have to sort them as well. So logic for sorting integer and logic for sorting floats and logic for sorting string is exactly the same. If it's allowed for me to compare both the strings. So my sort function can take in parameters which are of different type, but will still go ahead perform that operation of sorting. So I have an opportunity to replace the type as and when I want. The generic code. Generic means a code that is not binded to a particular type. The code that can run on with variety of different types. So I'm saying T is of some type. So you pass any type of data to this, the code will run. But then when I have to call that function, the stories are totally different. How do you call those functions? How do you use those functions? The story is totally different. But generics gives you an opportunity to write a program where while you're writing the code, you are not aware about the date type. While you're writing the code, you're not aware about the date type. While you're running the code, you'll be aware that I want this function to work on so and so type. So if I want to give such additional information, saying this particular parameter is unknown to the developer, but known to the user of that particular function and is running that particular code. So for generics also, we can use this particular feature of annotation where we can say what is that particular element that we are trying to add. If you go through the docs, it will give you some more information about the concept of typing. Where is it? Here. About the concept of generics. I was talking about generics. So it gives you an opportunity to write code which are not binded to a particular type. Okay. And there is a lot to it. Contravariant and bounds and other things, which we'll look into later. It is very good for us to understand. Suppose if I have a list. Now list can be of integers, list can be of students, list can be of grocery items, list can be of anything. Na? Not necessarily list has to be of only one particular type. List can be of different types. So such generics codes, when you are writing, we very widely use these concepts, which will enable you. Then there is a concept called as any type. And this, those who learn the languages in detail, you'll realize C++ also does the same thing with the same name. We have any type, we have generics. Java will also have the same thing. So learning the next language will be easy for you. Why? Because concepts are the same. Only thing we'll have to look into is the syntax. Okay. So there are subtyping also, type, okay, any string, string literal, never. There are so many things. We'll look into those things in more detail when we look at concept of generics. But that's something which is optional. There's a concept called as optional also. Optional. Okay. That means I can say in Java, we say there is no compulsion for that function to return value. It may optionally return an integer. It may return integer. That means there is also possible that it may not return an integer. So we want to specify, write a function saying, oh, it may return this or it may not return this. That's also something which is possible. So here, in such cases, these annotations play a very important role. They help us to write generic code. They give us some information about that particular type. So we are aware as to what kind of data is expected to that function or what the function is going to return. So it becomes quite a handy tool for us to use when you are working with Python, especially to understand whether we have made use of that particular code in a correct fashion or not. So in typing, you'll have the type var, you'll also have text. There are a number of things which are there. You can also have user-defined data types, which I'll teach you how to create a user-defined data type and how to use them. You can give the type some name, like I give T, you can say S, you can say Z, whatever is appropriate for that particular scenario, those things can be done. And if you want to do that, you have to have this type hint. And for that, this concept is necessary. Type hint करना है, तो आपको annotation की जरूरत है. Have you understood this concept? Although we haven't yet seen all the applications, I just give you a glimpse about it. I am sharing the link to the PEP so that you can also read more about it before even we discuss it in the class. This would be a topic that we'll come across when we learn generics in Python. I'm just sharing a link. You can just scroll. Don't worry if you don't understand much of it, but you can just have a look at it. So I'm just sharing this. It's PEP of 484. You can just search by type hints, PEP 484. That's good enough. Any questions? I have been constantly speaking. Any questions, anybody? Any questions?
No, sir.
Monica, any doubt?
No, sir.
Now that you are aware of this concept of typing and annotation, so you should not be surprised when we start using this very often in our code. Okay, and keep in mind, give these annotations. You don't give these annotations, that will not have any impact on to how the program runs. Program will still run without annotation. With annotation, the program will run. Will give the same result. But if you want to monitor whether the types have been used correctly or not, okay, then these annotations play a very important role. Where The tool like MyPy can scan your code and check whether the usage of the function is correct in the program or not. We have just seen annotation to that level. So MyPy was a tool which was doing static typing, checking at compile time, or even before you run the program, whether all the calls to the functions are appropriate or not. That is what it had checked. So we can have a variety of such tools. Sometimes annotations are meant for the compiler as well, but they are very advanced feature. When we talk to the compiler, tell the compiler, oh, do this thing for me automatically. ऐसा भी कुछ किया जा सकता है. But one thing is for sure, with or without annotation, the program will run the way it was running. But if you want to communicate through our program with some other tools, annotations are way to do it. Comments do not talk to other tools. Annotations are mechanism through which we can express something, and that can act as a mean of communication between your program and the tool for which that annotation is meant. It's a very advanced topic which we'll discuss in later. We just saw how to use it for function parameters. Any questions? So hearing no questions, let's move ahead and let's move to the next topic for our discussion, and that's iterables. Now, believe me, the time that you're spending learning Python, and that to Python correctly, will help you with all other languages. Java, same thing. C++, same thing. Syntax may be slightly different. So concepts clear hone chahiye. So even if the language changes, it doesn't really matter for us. We know what it means. What is the purpose? So when you read that tip, you'll always find goal, a rationale behind it. So that's the most important thing that you should focus on. Why was that enhancement introduced in the language? What are the rationale for introducing this? What is the goal for introducing this particular feature? That is purpose you should understand, the purpose of that particular feature. So if the language change, what we need to do is, how is this to be used in this language? That's the only thing that we learn. So next topic is also something that will help you master all of the programming language. So I said Python is a very good language to begin with. So like C के लिए भी अच्छे basic concepts cover हो जाते हैं, for Java, for Python, for Haskell, for any functional programming also, all the fundamentals that you need to know, you can very well touch it through C++, through Python in an easier way. Because Python doesn't enforce. If I teach you the same concept in C++, they are very strict, very rigid. It's like a military regime, see, writing program in C++. Flexibility means opportunity both hai, but very strict. This is meant for this only. So there, if you fumble, it will immediately generate lots of errors. Python is flexible. So Python's flexibility at times thought to be, means it's actually used good. Like if you are careful, it's good for you. If you are unintentionally commit a mistake, it will ignore that. C++ is like very strict, like I said, military regime. It will not ignore anything. Smallest mistake, it will stop. Okay. Python will give you a chance to continue. Good and bad things. So let's talk about the next topic, that is iterable. Now, when I say iterate, repeat, like loops, you iterate over the set of elements, you move over the set of elements, you iterate. So we have iterable, something that can be iterated over, something through which we can move over. So anything that you can use in for in on is iterable, list, string, files, and so on. So if I write a code, something like this, we are here, and let me directly write the code. Suppose if I have a string, I say S is equal to ABCD. Okay, ABCD. And I say for C in S. So I'm iterating over those elements. I say print C. Okay, it has iterated over those elements. So it has cycled over all the elements. It has visited all elements which are present. Likewise, there could be a list also. Suppose there is a list over here, and the list had some elements, 23, 45, 56, something, something, something. And then we try and iterate over those elements. We have iterated over the elements. So lists are iterables, strings are iterables. So I have this collection of elements, and we can move from one element to the second to the third, So anything that we can use over here in for loop is iterable. Okay, so a string was iterable, a list is iterable, a tuple is also iterable. So all these are iterables. You can iterate over those elements. So let's make it a tuple and see is tuple iterable. Oh, I shouldn't have done that. Here we go. Arey nahi yaar. I should. Here we go. Arey kya hua? What happened? What happened? It is iterated over the tuple as well. So list, any collection of elements we have, any, mark my word, collection of elements that we have. String is a collection of characters. List is a collection of elements. Tuple is also a collection of elements. So when you have this collection of elements, we can iterate over those elements. So we had these collections. So what is an iterator? We talked about iterable. Anything that we can use in this for in loop is a iterable. It is a group of elements and we can move from one element to another. So what is an iterator? It is an abstraction. Now you need to understand this concept very carefully. Yeah? And those who come from C background will appreciate. Say suppose anybody amongst you who has done C language.
Yes, sir.
Now suppose in C language, if I have an array and if I have those elements inside an array, suppose it was an array of 5 elements and I tell you print all the elements inside that array, what would you do?
Run a for loop.
आप for loop लगा दे. What would you say for element in that array and it will print all the elements? Would it happen?
No, sir.
No.
Index
You,
take it.
suppose, what would you do, Prithviraj? How would you write a for loop? Say there is an array A, and integer array in C. Suppose int A. Nowadays we have interpreter for C language as well. Huh? So you don't have to write the entire program. Let us do that just for sake of fun. Huh? So normally if you have to write a C program, you have to say hash include this, that, everything we have to do, and main, everything we have to write. Yes or no? So I have seen some interpreter for C as well. So let's search if we can quickly find them. ये मेरे पास साइन अप करना है ना. I don't have to worry. Let's see. Can we do it or not? Let's do check on online as well and over here as well. Okay, C++, C what it is. Let's do that. And I'll write a code. See how do I write a code now? Watch it. Say int, I hope you can see it. Int A of 5 is equal to, I initialize that array 2, 4, 6, 8, 10. So I initialize that array semicolon. Those who know C language, those who don't know, don't worry. Just see how much efforts we have to put in. Then I'll say for, and I'll define an integer over here. Int counter. I'll say for counter. I could say int counter over here as well. That's also allowed nowadays. Int counter is equal to 0. Counter less than 5. Counter plus plus. That's what you write, yes or no?
Yes.
Printf. Okay, how will you print now? Tell me. Data is equal to, what do I write?
D, person D.
Person D, comma,
Array,
Person
it's
array of.
R counter.
Okay. Now we have written this code. I run this particular code. I got data, and then I say slash n, so it will go to the next line. Okay, it's not a C session, but I just want to tell you something. Here we took the responsibility. This is imperative style of writing code, old style of writing code. Old, why do I say? Because you are taking the responsibility. Array का पहले element का index 0 होता है. Last index is size -1. Size 5 है तो 5 - 1 is 4. तो we'll go till 4. Every time I have to increment the counter. Then when I say a of 0, a of 1, a of 0 पहले 2 देगा, फिर a of 1 ये देगा. Counter का value change from 0, 1, 2, 3. So a of 0 will be this, a of 1 will be this, a of 2 will be this, 3 will be this, 4 will be 5 होते हैं loop में से बाहर आओगे. गलती से आप काउंटर इज इक्वल टू 0 की जगह 1 कह दिया होता तो इन दैट केस यू विल नॉट गेट द फर्स्ट एलिमेंट. गलती से यहाँ 0 तो लिख दिया आपने, बट यहाँ इंस्टेड ऑफ सेइंग लेस देन 5, इफ आई से लेस देन और इक्वल टू 5 तो गए काम से. देयर विल बी सम गार्बेज वैल्यू दैट यू गेट. Data 0, where is the 0 coming from? So you as a programmer are taking unnecessary responsibility to, I just have to iterate over, visit over all the elements inside this array. So you need to know what is the subscript of the array. You need to know what is subscript. What is the last index of the array? You need to know that. You need to know how do I increment that particular counter, and then you have to access every element in saying array in के अंदर का ये element access करो and so on. So here we say we take unnecessary responsibility. Whereas over here we are saying iterator is an abstraction. All this I'm doing just to explain one line. Iterator is an abstraction. Now let me explain you what this line means. Oh, very important thing. You're going to come across this term abstraction again when you look at object-oriented programming in Python. So it says iterator is an abstraction. Okay. Abstraction for what purpose? Okay. It is an abstraction which will hide the complexity of how to iterate over the elements and will enable you to focus on the work that you want to do. The work over here was to iterate over the elements. But then as a C programmer, you not just have to focus on the requirement that you want to, the work that you want to do, you also have to focus on how to get that particular work done. As in, when we have this abstraction, it says, don't worry about the complexity. That's all hidden. You tell me what is to be done. I'll get that done. So iterator an abstraction means underneath there is a for loop. For I equal to 0, I less than counter I plus plus, all these things are there. All these things have been hidden from you, so that you can focus more on your logic than to worry about how it is being done. So iterators are special codes or special functions or special items or functions, something which is special, which knows how to iterate over the elements. Now, again, one more important thing. There can be different types of collections. Some of them are ordered, some of them are unordered. Remember, set is unordered, list is ordered. Sometimes you may have more complex structures like map. Okay. Now, the technique that we'll use to iterate over a map is very different than the technique that we'll use to iterate over a tree or something, a list or an array. So the syntax of iterating over different types of data may be probably different because the data is organized in different way. Just to show you a glimpse about it, suppose if I take a tree structure, so if I say data structure tree, and let's look at the images. This is the tree structure. But if I say data structure queue, and if I look at images, this is queue. The way the data is arranged in the queue is very different than the way data is arranged in a tree. Correct? Is very different the way the data is arranged in a graph. Look at this. The way of arranging the data is logically different. Now, how do I visit all such elements? Look at this. How do I visit all the cities or pathway, whatever it is, all the things? Oh, the logic will be different, how to visit them, as compared to the logic that we'll be using to iterate over a tree will be very different as compared to the logic that we use to iterate over such a list. I have a list and I can just go from first to the second, second to the third, and so on. The point is, with all those internal details, suppose if I tell you visit through a tree or a graph, unless you do not know how the tree is organized, how the elements are stored in the memory, can you write the logic to visit all elements inside that collection when you do not know how the data is being stored? Can you do that?
No, sir.
No. So for you to come with a logic so that you can access all elements or visit every element inside that collection, the first and foremost is you should know how the data is being arranged. Then you can come with a logic. But then with this abstraction, it tells you, oh, what is your requirement? You have to visit all those elements. Don't bother about how the data is stored in the memory. You just let me know you have to visit. I will hide the complexity, the implementations that goes behind it, the complexities, and I'll give you a simple for loop. And that for loop will take care of visiting. But every time it's visiting through that collection, the logic that is running behind may be totally different. But for you, it's simple for loop for a data element inside that collection. Now that collection is in graph or a tree or a set or a linked list, that's nothing of your concern. The for loop knows how to visit through that iterable. So list is an iterable, graph is an iterable, set is an iterable, any group of elements is iterable. I can visit every element inside that collection. Now, the logic for iterating over elements inside that collection is different. Python provides you abstraction, means it hides the complexity of how to visit those elements and provides you a simple interface like for loop, which enables you to get your work done. आपको visit ही करना था ना, तो it will help you visit that element. You as a developer need not bother as to how that work is done. You focus on what is to be done. I want to visit every element. I want to delete. I want to print those elements. I want to add those elements to a list. You focus on your logic. Don't bother about how it is happening inside. How is every element inside that collection being accessed? That's abstraction. So iterable is that collection of elements. Iterable is that collection of elements. Iterator is an abstraction. It is a special object that has some special knowledge how to visit elements inside different collections irrespective of how they have been arranged. Actually, if I go into more details about it, we can talk about it for the whole day. Iterator for everything is different. The iterator which knows how to cycle through the string, it is different. The iterator which knows how to cycle through a graph is different. But then for the user, it is shown as if, oh, it's an iterator, it can iterate over that collection. So it's good for a Python developer because he doesn't have to bother about the complexities, need not know about the arrangement of data in the memory. He can focus on his requirement. I have to visit every element, so he can just use for loop. So that was that one statement that was mentioned over here. The statement was, iterator is an abstraction. Okay, I hope you understood what do you mean by that abstraction, which enables the programmer to access all elements in the container. Container, I use it's just a container, a set, a list, whatever may be the container, without any deeper knowledge over the data structure of this container object. Graph uses hash table. A map uses hash table. We don't know hash table. What is hash table? We haven't yet touched this particular concept of hash table. Although I just gave you a brief, but we have not yet discussed in detail what is hash table. You need not know as a Python developer how is the data being organized in the memory without having any deeper knowledge about the data structure of this container object. So every data structure, every container that we have, list, set, tuple, graph, the map, all of them are organized in different way to facilitate those operations. You as a Python developer need not know internally how is the data organized. You can store by saying append, add, or whatever it is. You can access all elements just by using a for loop. So when you as a designer tomorrow, when you create your own collection, it will be your duty to provide an abstraction. That means hide the complexity. Make it easy for the user to use your collection. Say you are driving a bike. Prithviraj, do you know how to drive a bike?
Yes.
How do you drive?
The first neutral and then what do you call?
Huh?
Turn it on. Turn the bike on. Switch on.
You go to the bike and say, please turn on.
No.
Then
Kick or start
you kick
button.
the bike and the bike starts.
No.
Then
If you have the start button, then you press it. Otherwise,
and don't you need the keys?
Yes, we
You
need
just press
key.
the start button. Even the bike is in the parking, you just put the start button, the bike will start.
No.
No. So you put the key in the keyhole, you turn the key clockwise. Either you push the start button or you press the kick. Correct?
Yes.
What happens when you push the start button? Did you ever bother? How did the bike start?
No.
No, that was abstraction. you know, this is what I need to do for that functionality to be utilized. I did not bother, or the designer of that device is so smart, he has hidden all the complexities. Do you feel there is some magic behind pressing the button of the vehicle starting?
No.
No, there is a lot of things that goes inside. I'll talk more about it when I discuss object and concept in detail. There's a lot of things that goes inside when you press the button for that engine to start. But all that thing has been hidden from you. Abstraction. You can focus on what you want and not bother about what is happening internally. Your objective was to drive a bike or start a bike, not to understand how that bike starts. So abstraction is something key when it comes to making use of, or the world is actually very complex. And we make it appear simple by using abstraction. We ignore the complexity so that we can focus on things that's the definition actually, but I couldn't resist myself from using the definition of abstraction. It says, ignore the complexity so that we can focus on what we want. Okay. And if I get into all the details, then life is mess. So iterators are such abstractions. So it says iterate is an abstraction which enables the programmer to access all the elements of the container without any deeper knowledge, means without you and me having deeper knowledge about the data structure of this container. So without knowing how is that container organizing the data in the memory, we can still access the data inside the container. So iterator protocol, it says the built-in function itr takes an iterable object and returns an iterator. So you pass a string that is iterable and you will get an iterator. Remember, for a moment back, I said the logic for iterating over a graph is different than the logic for iterating over a string, and that is different over logic for iterating over the list. So the iterator for list is different, iterator for a graph is different, iterator for a string is different. So I want to get the iterator for that collection. So if I want to have an iterator for that particular collection, then I'll use this function itr. I'll pass my collection any iterable, and what I'll get is an iterator which knows how to iterate over this iterable. I hope these words are not confusing, iterator and iterable. Can somebody put in simple words what you understood by the term iterable and iterator?
इटरेबल पे इटरेटर इटरेट करता है.
Okay, put in सामने वाला अभी we have spoken about it, so you'll understand. आप दो बार word iterate use कर रहे हो, तो I understood it, but put in your own words, simpler words. So आपके sister को या brother को समझाओगे तो समझ आएगा.
इटरेबल कलेक्शन ऑफ डेटा है.
Okay, that's very good. Iterable is any collection of data. Very correct. And
और उस एलिमेंट को एक्सेस करने के लिए इटरेटर यूज किया जाता
की जरूरत है. परफेक्ट. तो उन एलिमेंट्स को जो उस कलेक्शन के अंदर है, उन एलिमेंट्स को एक्सेस करने के लिए हमें इटरेटर की जरूरत है. ओके, सो एनीबॉडी कैन, ओके, जरूरत है बोला, बट व्हाट इज इटरेटर?
Complex code that actually accesses the element for us.
Okay, so code name, it's an object in Python. It's an object in Python. Its implementation may be complex, which knows how to access elements inside that particular collection. And why does it know that? Because it is aware as to how is the data stored in that particular collection. Are you all getting it?
Yes.
So data is organized in different ways, which we'll learn in data structures. Okay, data is organized in different ways. So the technique used to access those elements are also different. So iterator knows how to access those elements which are stored inside the collection. The problem is there is no one logic that we can use to access elements in all collections, because different collections have different way of organizing. So for list, I need a different iterator. For set, I need a different iterator. For a map, I need a different iterator. For string, I may need a different iterator. So I need different iterators. So how do I get that iterator? By calling function itr. So if I call this function itr and you pass your collection, it will study that collection and give an object, and that object you can use to cycle over the elements. Each time we can call the next method on the iterator that gives us the next element, and it knows what is the next element. You don't have to bother. It may be ordered collection, it may be unordered collection, it will give you. If there are no more elements, it raises stop iteration. So that means when you have cycled through all the elements, it will give you stop iteration. So we have this function called as iterate. It takes in two parameters. First is the object that is iterable that you would like to iterate on. Second is sentinel value. This example I'll give you later. You may say, okay, stop after some time. So when to stop? That's a sentinel object. That's optional though. Especially that is used to represent the end of the sequence to say when to stop. So let's make use of this iterator and iterable and use this ITR function to iterate over the collections. So this will take in two parameters. First parameter is required argument, that is the object, that's the container. And second is a sentinel value, that's optional. Okay, and wherein we tell when to stop iterating over the elements. Okay, I could say. So I want list of all the cities in Maharashtra, and I don't go beyond Aurangabad. So I can say that all the cities on the route to Pune to Bangalore or Tumkur. So don't go beyond Tumkur. So I can put a sentinel. So stop at this place. I want marks of all the students, but stop at 60. Don't go below 60. Start with 100 and go till 60. So object that has to be callable if you want to give a sentinel value. Okay, so we'll look into these things slightly later. I'll look into yield also later. Let's focus on this iterator and iterable. Let me open up the right code for you so that I can demonstrate this particular concept for you all. Just give me a second. Meanwhile, you can have a look at the source code, this statement, and I'll open the code meanwhile. आपको क्या दिखा दे रहा है, स्पाइडर या कोड? स्पाइडर या पावरपॉइंट प्रेजेंटेशन? PowerPoint, na? Okay,
Yes, sir.
go through. Meanwhile, I just search the right code. Example के लिए. Got it. Let's start with the simplest one first. Have a look. Pay attention. It's just like whatever we have discussed. Huh? I have a list and I want to iterate over list. I can use a for. I say for element in this list, print element. So when I do so, I'll iterate over all the elements inside the list. Have you got it? 1, 2, 3, 4. Again, all elements over the list. Oh, I have a string called as Python. I want to iterate over Python. So I say for character in Python, iterate all elements. Again, Python, have you iterated over all elements? Oh, I have a dictionary now. We say for K in X1, Y2, it's a dictionary, yeah? Key value combination. Oh, it has iterated over all elements, X and Y. All the keys it has given, not the values. If I wanted to have all the things, suppose I have this player dictionary where I have the player name and his score is what I have, and I have to iterate over. I could say player dict dot items. Remember, it will give dict items. That means name and value both, key and value both. So I'll say Sachin has scored 101 centuries. Saurav had scored 48 centuries. Rahul had scored 65 centuries. So I want to know both the things. Oh, let's iterate. Sachin has scored 101 centuries. Saurav had scored 48 centuries. Rahul has scored 65 centuries. You got it. How do you do that? We said the name. Unpacking is what we have done. So when I say player.dict items, it gives you player.items, it gives you dict items. It's like a tuple. So I have unpacked it into two parameters over here, name and century, and now we have accessed them. But then the way the data is organized in the dictionary is very different than the way the data is organized inside a list and how it is organized in the string. But then you and me as a developer don't have to worry about how that things are happening. We can only use this. It's an abstraction that we have. We need not bother about how the data is being organized. Just use the for loop that will do the magic for you. Now, suppose I have a file called as data.txt. we are currently inside the programs folder. So let me just check whether we really have a file called as data.txt. So I'll go to D drive. Files are also iterable because files, if it's a text file, you'll have lines inside the file, you'll have words inside the file. So collection of data. So we can iterate over a file as well. So let's do that. Python, you don't have to open, close file, nothing. All those complex, say I have to read a file. The basic operations that we'll have to perform while reading a file is, we'll have to first open a file, then we'll read the data, then we'll have to close the file. But this for loop will hide all those things from you, all the internal details. You can just say, I want to read this file. I want to iterate over the lines inside the files. It will do that. It's abstraction. It's all hidden from you. So let's do this. Programs. And I have to check whether there's a file called as data.txt. I say data.txt. Do we have one? Oh, we have a file called as data.txt. Let's see what's there inside this file. Type data.txt. Oh, it has a word called as first line. That's a single word that is there. Let's make some changes. Notepad, data.txt. It's first line, I add second line as well. There are 2 lines inside this file, correct? There are 2 lines. Let's run this code. Because there are no such file called as data.txt. Okay, let me save this. We are in C: programs iterator. Let's see. Let's run this code once again. It says no such file or directory called as data.txt. Don't we have it? Yeah, data.txt. Okay. Sometimes it so happens whether let me copy this. I'm not going to make any change. I just save it over here. I'll save it in a separate file called as ABCD E add F ABCDF is the file name. Okay, anyway. And it says open data.txt. I have not given the path, so it should look into the current directory. Let's do it. I say Python ABCDEF again, first line, second line. Code is the same, huh? For line in open data.txt. So I'm saying for line, that means get me one line, get me the second line. From which file? Data.txt. And every time I print that line and I say end my kuch nahi, that's okay. Because we had pressed enter at the end of the line. So that line has come on to the next line. So that's how we have iterated over the data inside the file as well. The point that I'm trying to make is files are also iterable. It is not just that the container file is also a container, right? It contains some data. So that's also iterable. So we iterated over a file. I have a list and I say player in player list. Oh, a list of strings here. So I can iterate over the things. I say I have a player list. These are my favorite players. I come from a different age. And now what do? I'm not going to use for loop. I'm going to use this ITR function. What do I pass to this ITR? As we said in the notes, we'll pass our iterable. It says a built-in function ITR that takes iterable object and returns an iterator. So now look at this. This function called as ITR takes a list. List is an iterable object, collection है, and returns an iterator. So आपका iterator आएगा. So if I print this, look at this. If I print this line number player ITR क्या है? So if I run this particular code, it says okay, it's a list iterator. That means this object knows how to cycle or visit elements inside a list. A list iterator है. That means list iterator has a knowledge how to iterate over list. But then how do I use it? Oh, I can just call method called as next. So I say, and I pass this iterator. So if I call this method, okay, I'm at line number 42. I'm at line number 42. Watch, I'm at line number 42 here. And I run this code. Oh, it has got Sachin. Okay, I'm at line number 42 only. Oh, it gives Saurav. I'm at line number 42 only. And it says Rahul. Alright, I'm not going to the next line. Doesn't matter. Every time you say call this method next, it will give the next element inside that collection. You don't have to bother as to where this element came from. Okay, Anil. Okay, and karte Anil kahan sa tha? Oh, okay, Javagar. So wherever we are, I run it once again. I got Java. Now, if I go through it, are there any more elements left inside this particular iterable to iterate over? No. So in that case, it will raise a exception. Java ka lage. Okay, let me select this and run this. It says stop iteration. Why stop iteration? Because you have exhausted the elements inside that container. There is nothing more left inside that container for you to visit. Now, I have a dictionary this time, player, and there are centuries that they have scored. I get an iterator for dictionary. But the best part is we need to print and see what is it. Okay. तो कहाँ प्रिंट किया था ये जो हमने यहाँ प्रिंट किया था so let's print it over here as well, and there is a reason why I'm doing that. So first we had list iterator. Let's see what is this. If I run this, it's a dictionary key iterator. That means it will iterate over the keys inside the dictionary. So we had a list iterator earlier. Watch it. We had a list iterator earlier. List iterator knows how to iterate over list. A dictionary key iterator knows how to iterate over keys inside the dictionary. How to iterate over the keys inside the dictionary. Now, if I say next once again, next of this, it'll give you the next, all the keys. Look at that. It got all the keys. Sachin, Saurav, Rahul. Can you see? Sachin was the key, Saurav was the key, Rahul was the key. So I got all the keys. Instead of calling this global function next, we can call a built-in function or the method inside iterator called as next. So if I have a iterator for string, let's print that as well. Huh? Let's see what is this. Huh? So if I run this, so it says, something wrong happened. Oh, yeah, now it's only iterator. It does not play iterator, it was iterator. Let's run these two lines, 57, 58. 57, 58. Let's run these lines. It says a string ASCII character iterator. So you have a string of ASCII characters. So this string ASCII character iterator knows how to iterate over string containing ASCII characters. Okay, I'm call method next. I got P. I call that method again. So I'm just going to keep this thing selected. And I'm just going to keep on calling this particular statement. P, Y, T, H, O, N. Got all the characters. It knows how to iterate. Every time you say next. But after N, if I go on to iterate, it says stop iteration error. So it has to stop. Look at this. Oh, we haven't seen zip. Okay. Zip kavi. We had learned this concept of zip. Huh? So if I have two lists and I want to map them together, so I create a zip, and if I check this, it says it's of type zip. And for element in data, if I go on to access those elements, I'll get them as tuples. So if I have a zip, it can be iterated only once. Huh? So I just iterate it again. If I want to iterate it again, remember, it would rather fail. It would rather fail. Remember that it can iterate only once, we had talked about. Huh? Now, I take a zip of both the list once again. I got an iterator for it. Okay, we got an iterator for it. Let's print what this iterator is all about. I say print here. So I select this. I run this. Oh, it's a zip object at so and so. Okay, zip iterator. Okay, if I say next of this zip object, it's an iterator actually. I got 2, 4, 6, 8. Done. Now if I go on to iterate over it, it will say stop iteration. So I could have done this by using next method as well. But now that we have iterated over, there is nothing more to iterate. But if I had created this zip object first, and then I iterated, call this next method several times. First time, I need to create this iterator as well. So I create this iterator. And now if I call this, there are two options. Call a global method next or a member function called as next. Again, I'll just select this line, call it several times. एक बार आ गया, second time, third time, fourth time, now error, stop iteration. Look at this. I have range and we can cycle through that range. So range 1, 10, 2. That means every alternate number from 1 to 10. I hope you remember. Step is 2. So we say for odd in odd numbers and we print the odd numbers. Okay, but what's going behind the scene is an iterator which is in working. So what do? I create this iterator for the range. range 1, 10, 2. Okay, and then I print what is the type of that iterator. Okay, it says it's a range iterator. So this range iterator knows how to iterate over a range. Fine, so let's use it. So I can call this next 1, 3, 5, 7. I can call this method next as well, 9, and then stop. It's consumed. Likewise, if I have random int, oh, that's nothing with the random int, that's different. So that was a basic idea about iterator. Have you understood this concept, everybody? Yes or no? There is something called as iterator tools that also we'll discuss later. But remember, we always have iterator for various things. For list, there's a separate iterator. For file, there's a separate iterator. For everything, there is a separate iterator which is available. Now, what I need to give an example is only about what next? I have to give an example about the sentinel value. Okay, what is the sentinel value is what I have to give an example. So let me give an example for the sentinel value and how it should not be used. Okay, so a lot of times we confused as to how the sentinel will come into action, but we can use this at any place. So this was quite an advanced concept. अगर आपको समझ में आ गया है, तो you should be happy. The reason is because we'll be using similar feature later in almost all the languages. Okay. So let me just open up an example for you where I'll give an example of a usage of sentinel value with iterator. Then I'll share these examples also with you all. Just give me a second. I'll open up the code so you can also have a look at what I'm trying to search. No, it will not be the right time for me to talk about. It will require us to know something more. Okay, let's do it. Here I can explain. Suppose I have a text. Failure will never overtake me if my determination to succeed is strong enough. Okay, that's a good statement. Huh? But I have a good statement. And it's a plain text that I have. It's a plain text. Watch it very carefully. It's a plain text. Failure will never overtake me if I have determination to succeed. If my determination to succeed is strong enough. I say text.iterator. So ये text जो है इसका iterator कौन है? Oh, there is a method wrapper called as itr for string object and so on. Okay, fine. So I get this iterator saying later iterator. Watch it. I'm saying later iterator. And if I really print this, let's see what it prints. It says, okay, it's a string ASCII iterator. That means every ASCII character from that string, it is going to iterate over. Very important thing we're discussing now. So if I say for later in the later iterator, iterate over, I got a 1 character from that particular string. But I want to iterate over words. So I say text.split. So I can split and iterate over every word inside the string. Okay. No. I say text.split. Okay, once again, I say text.split. I get the iterator object, word iterator. I get the iterator object. I say next. Okay, failure will never overtake me if my determination to succeed is strong enough, and stop. Okay, I could have made use of it in different way. How? I get this iterator object once again, and then I say for word in word iterator. Oh, iterable hai na? I can use this iterable at the place of this container as well. So every word in that iterable, it will iterate over. I got all the words. Likewise, I can say for word in text.split, that gives me a list, if you remember. So actually, I'm having list iterator to cycle through all the elements. But then I could say iterator list.split. And I want to check what type of iterator it is. It's a list iterator because split method always returns a list. Can you see this? It's a list iterator what we have. So I say for word in word iterator, print every word. That means that I'm cycling through that list, getting every word every time. Okay, but then when to stop? I have not given. Sentinel value, we did not give. So I have word list, happy, sad, fun, game, flower. And I have iterator, which will enable me to iterate over it. So I say for word in word iterator is what I do, and I iterate over all the elements. Happy, sad, fun, game, flower. Now what do I do? I have word list once again. Happy, sad, fun, game, flower. That's my word list. I have an iterator for it, but this time what I've done, I'm saying iterator, I have word list.pop. That means pop every element from the list. It has to be a callable. Huh? The object has to be callable if I'm going to use a sentinel value. I'm saying stop when sad is encountered. So I'm now, last time when I use this word iterator, note kijega, it has iterator over all the elements inside this particular list. Watch it once again. It has iterator over all the elements which are present inside the list. Now I'm saying, no, there are a list में से एक element pop करो. So I have a callable object. Pop is a method. Methods are callable. I can call a method. I cannot call a list. I can call here. What I have given is a list. Here what I'm giving is a callable. Word list is not callable. Pop is callable. It's a method which is present inside a list that I can call. Okay. And I say, okay. So I've given my sentinel value as sad. Watch it. Now I'm going to use an iterator saying for word in word iterator. This is a word iterator for which the sentinel value is sad. Now I cycle through the elements. Watch it, what's happening. Flower, game, fun. Sad, it has stopped. Okay. Order, we are not very sure. But flower, game, and fun, it has stopped when sad was encountered. Okay. So moment it encounters sad, it has stopped. Till the sad, whatever elements it can iterate over, it has iterated all of those elements. Flower, game, fun. That means a reverse order में जा रहा है. Flower, game, fun, and sad आते ही रुक गया. Suppose if I add one more over here, saying fruit. Now with this understanding, we should probably get first element as fruit while I iterate over. Let's see. आगे fruit, flower, game, fun. Fun के बाद wait कर रहा है. Why? Because central value sad has been encountered. But for you to use the central value, here you cannot pass iterable. Word list is iterable, but I did not pass word list. I said word list dot pop. So if I had to use a sentinel value is the indicator indicating us where to stop. So if I'm given a sentinel value, then the first parameter that we're going to pass to itr function has to be a callable object. Likewise, I have this file called as data.txt. I have this iterator which will iterate over all the elements. So I can say file iterator of my file, and we can iterate over all the elements. But I'm going to use sentinel value here as well. Oh, this I cannot type it over here because the file is in the current directory or in D drive. So I either have to give the entire path. So let's give the entire path. So that problem will not exist. I say the path of that file is :/python/ program/this. That's the path. Now I'm going to iterate over all the elements. It will print all the lines. First line, second line. We had an iterator of type so and so, text I over apple iterator, what it is. But the point is we could iterate over all the elements. So once I have this iterator, I'll do it again. Once I have this iterator, using this iterator, I can iterate all the lines inside that particular file. I get the iterator once again. And then I iterate over all elements inside that particular file. Again, first line, second line, we could do that. Now, what do? I open a file, that's okay. I say iterator hai. Read line is a method that I'm going to call, and stop when end is encountered. Okay. I did not have end inside that file, so I'll type it. We have this file called data.txt. First line, second line, third line, end. Fifth line, sixth line. So these are all the lines. Huh? बीच में end है. Can you see this? बीच में end है. But after end, I have pressed enter. Now, if I run this particular code from here, it will run because I'm giving the entire path. Okay. So if I'm running this, it will print all the lines, including end. Okay. First line, second line, end line, fifth line, sixth line, everything. But what will happen now is story is different. Here we go. Now I'm giving sentinel value as end. I am calling a method called as readLine. So from the file object, when I say readLine, it will read one line for me. But iterator knows how to go to the next line. So I'm saying for word in file iterator, word print karo. But I have given sentinel value as end. So to stop when end is encountered, let's run this particular code and see. It says first line, second line, third line. It has stopped. The first line, second line, third line. उसके बाद end था, fifth line था, sixth line था. But it has stopped moment end has been encountered. That's because we had given sentinel value as end. But note, every time I give a sentinel value, the first object has to be callable. Here I called a method called as readLine. Here I had called a method called as pop. Unlike last time, you cannot pass a iterator. You cannot pass only the object. I have to pass a callable for that particular purpose. Have you all understood this concept of iterator and iterable? Monica and Ashish? Okay. What I'll do is I'll just share these examples with you before we stop for today. Please make sure that you go through these examples. They are very important. These are, we are just going on to the advanced topics now. And if you miss out these topics, it's very difficult to understand the concept. Huh? So I have which all files I took right now. Iterator dict, iterator, sentinel2 नहीं देते हैं. Iterator parameter. So let me share this file with you. Iterator parameter. Files. Iterator also. Dictionary also I'll share. So what I have not discussed with you all today is a concept called as iterator tools. Okay, that's for tomorrow's session. I think today's a lot of new concepts we have learned. So we'll stop over here today. Have you all received the files? And no assignments for today. I want you to go through this particular code. Okay, understand how it really works. If there are any questions, you can ask me before I go ahead. One level higher in this particular discussion when we meet tomorrow. Any queries, anybody?
No, sir.
No? So with that note, we'll stop here today. See you tomorrow at same time.
Yeah,
Take care.
tomorrow.
Love you all. Bye-bye. Monica, you saying something?